Hey there folks, in this video we're going to be doing some more review style problems. So I'll have an answer key to the review sheet up here in a sec. If you want to pause the video to get that, go for it. Then we'll go through a few just practice style problems and then we'll call it a day. So this video should go pretty quickly. All right, so first and foremost, as promised, that review sheet. If you guys want or need to see any of the work worked out, here you go. Some of these problems were examples that we had done in previous videos. So if number 3 looks familiar, that's why. Shift it over here. Again, if you want to pause the video at any point, please feel free. And now let's get into some problems. Okay. Straight up skill style problems. First one, evaluating a logarithm with a different base. So log base 3 of 25. 3 to what power is 25? That's not going to be a clean number. So if I can't evaluate it mentally, right? I know 3 to the third is 27, so I'm expecting something smaller than that. We'll have to use change of base formula. So change of base formula, translate this to use common logs. Easy way to remember which number goes where. The base is always on the bottom. So base 3 means we have log 3 on the bottom. What we've done is we've taken a logarithm that has some random base number, and we've changed it to now be two separate logarithms, base 10. These are called common logarithms. Straight to your calculator you go, and you'll get roughly 2.93. Number 2, the natural log of 26. There's really no thinking behind this one. You just go straight to your calculator, press the LN button, and it spits it out. But basically that's saying e, the exponential base, e to what power gives you 26? That would be 3.258. All right, let's get into solving equations. Right now I'm looking at this equation 4 to the power of x minus 5 plus 3 equals 21. And I'm noticing part of my exponent is unknown. So I'm going to massage this thing out, and I'll get to a point where part of my exponent is going to be unknown. I'll be stuck in exponential form, which is what this is written out in now. As soon as I get stuck in exponential form, I have to translate to logarithmic form. Vice versa. If you're ever trapped in log form, go to exponential form. So first, let's kick that 3 to the other side. Excuse me. So 21 minus 3. And now, as predicted, I'm trapped. I am trapped in exponential form. I'm going to rewrite this in logarithmic form. So the base was 4, the argument is 18. Log base 4 of 18 equals x minus 5. Well, this left side can go into my calculator if it's written in the change of base format. So this is really a common log 18 divided by the common log of 4. Well, everything on the left, that's now calculator work. When you do this, make sure you're rounding to 3 or 4 decimal places. And to solve for x, we'll just move that 5 over to the end. So this would be 7.085. All right, on to number 4. We have 2 times the natural log of x plus 2 equals 12. So the general process, we're going to divide 2 to the other side, but then we're going to be stuck. Part of my argument is an unknown. I'm stuck in logarithmic form. So we will translate this out to exponential form. Remember, with natural logs, our base is automatically going to be e. So first, let's divide out the 2. I'll get the natural log of x plus 2 equals 6. But now I'm trapped, so I need to go to exponential form. Again, the base was e. So when I go to exponential form, I go base, and then I swoop around the equal sign. So e to the power of 6 equals x plus 2. The left side is straight into the calculator. And then we'll subtract 2 to the other side to get our answer of 401.429. Not too shabby. All right, last one here. This is going to be a fast video. Again, part of my exponent is unknown, so I will be trapped in exponential form, which means, spoiler alert, we're going to have to go to logarithmic form. So our goal is to get the exponential base term by itself, so that 4's got to go. We'll divide 4 to the other side. 26 divided by 4, 6.5. At this point, I'm trapped. I'm stuck in exponential form with an unknown exponent. So let's go to logarithmic form. I'm dealing with a base e, so I have to use a natural logarithm. And right here, that e is not necessary for me to write. I just put it as a reminder that if we ever have a base e, we're using natural logarithms. This left-hand side here goes straight to my calculator. And then we'll divide by the 0.12 to solve for t. And there you have it. T would equal about 15.6. All right, that is it for this video. Pretty straightforward. We'll be spending a lot of the class time kind of going through these application problems. So make sure, as you guys are working through those, if you have any questions, please let me know. And as always, folks, good luck. Have fun. Be safe. Roll Tide.